Yeah, thank you so much.
Sure,
It is very helpful.
Yeah, I think it's something that comes out of Tim Mitchell's lab, because the woman I'm citing here was a postdoc with him. Okay.
Okay. All right. Let's resume. All right. I think it's pretty late for Karthik. He's in India, so let's shorten the roundtable to 1 hour. Okay. All right. So we have 4 topics in the roundtable discussion. So we're gonna have the application for 20 minutes, and data and technologies for 20 minutes, talent for 5 minutes, and talk about the future trend for 15 minutes. Right? Song will be the coordinator. I think, Peng, have you started recording yet? Oh, yes. Okay, thank you. All right. All right, so go ahead, start.
Yeah, thanks, Ray. So in this roundtable discussion, the first part, the applications, I think during the one-on-one, yeah, we get some feedbacks and ideas on what kind of topics, yeah, we can discuss. So that's our common interest. So the first topic, yeah, we can discuss around the product graph. So as you know that, especially during the COVID-19, right, shopping is becoming more and more important. And also in this KDD conference, there's a special session which is on the product graph. So I think regarding the product graph, actually, I just want to ask everyone, what do you think, what is the most valuable application for knowledge graph in the e-commerce? So anybody has any comments?
Yeah, based on what we have done at Walmart, right? I think the 2 most relevant places were search and recommendation systems. So
Makes sense.
Not sure if you're looking for anything specific inside search and recommendation, but those were the two areas where we ran a lot of bucket testing, and we found that in some cases it worked out well, some cases not so much, but those were the primary cases where we sort of tailored and focused a lot of our energy on.
I see. So search recommendation, you mean that how to find and recommend the shopping items?
Yeah, it's basically entity. So if you really look at search, right? If you understand the query really well, then you've sort of solved the problem, right? Then the rest is all about framing the query and then retrieving the document. But understanding the query is where we were really using our retail graph to be able to sort of interpret the user's query, extract all the entities, and then understand the relationship between them, right? So that was our primary use case for knowledge graph.
Can I ask? Do you guys care most about just the performance metrics, or you guys actually want to use the knowledge graph to help help explain the model's predictions? For example, to show user some kind of logical trends that the model is using.
We see an increased need for explainable models. We're getting a lot of that. So I get that from internal clients when they want to know about the taxonomy, but we're seeing demand from end users who want to know, why was I shown this recommendation?
I see. Thank you.
It's a hot topic.
Yeah, explainability of your model is super important. Can't be a black box anymore.
Yeah, so that raises another application of knowledge graphs, and that's for insights and analytics. Right, so this is one of our use cases as well. Aggregation.
So
yeah, I'd like to.
I want to add another interesting use case. Sorry, I sort of forgot my Walmart times on e-com. there was a very, very important use case. In fact, that was the motivation to start the whole retail graph initiative at Walmart, which was about home decor style. So the use case was complete the look. So let's say I buy I buy a couch, right? What are the things that I can actually put around it, right? So the idea was not just showing some, if you buy a couch, it's not about showing you sofa covers and things like that. It's mostly around how do you sort of construct your living room now? Because you've got a couch, most likely your living room or something like that. So what are the other things that can actually fit well with that couch? Because if the couch is gray in color, you don't want to be showing a yellow colored, say, carpet there, right? So this is something that we used to call as complete the look. And this was one of the major, applications of the work that we had done at Walmart, being able to build this kind of, experience, completing the look. We started with home as a vertical. There was always a desire to expand into fashion, but I'm not sure where it's headed right now. So
I'd like to echo that, right? The search and recommendation, indeed, two very big applications, right? Mm-hmm. To drive search, like you said, well, classic, one really need to understand the query. What are the entities, right? And then one can really figure out, the best way to deliver a good recall set, right? And also KG can fit into ranking because traditionally there's a lot of ranking signals are based on some tokens, some text, right? But now if we fit them entities and relationships, it sort of widens the signal set, right?
Yeah.
In addition, once we really understand the intent of query, the entities, then it gets easier to recommend related searches, right? If people are typing one query, you can also say, hey, are you also interested in this particular query, right? So you can recommend a related search. Yet another application that I see can be useful is guidance, right? At least in e-commerce, usually the inventory is quite rich, right? For a given query, you can see a lot of different things matching. Say Nike, the query is Nike. It's a really broad query, right? Then a variety of categories, right, of items can be a match. So in this case, how do we leverage a KG, right, to provide meaningful guidance?
You mean for query reformulation?
Not exactly reformulation, but rather, after the query execution, right, we present a whole bunch of ranked items. But then it's really rich, right, and diverse. How do we help users to show a meaningful set of categories, a meaningful set of structured data, right, to guide search, to tell the platform what's their true intent, right? So give them some clues. Do you really, are you interested in AT&T, right? This particular network provider? Are you interested in particular color, right? A size range, right? Or do you really mean in the basketball category, or are you more interested in the shoe categories, right? So those kind of things is what we call guidance, and those can also benefit from a KG.
So Joe, if I understand this correctly, so meaning if a user put in some relatively broad query, we kind of guess or guide them to specify their query. So for instance, if he searches for living room decor, then we will recommend to say, hey, are you interested in looking for a sofa, interested in coffee table, decorative base or something like that, right?
Yeah, precisely. It's like we need to show clues to help a user to complete or move forward with his or her journey, right? A user may start with a broad query, and here the results will be huge, right? How does the user move forward, right? So here, I think a KG can give clues on what are the most relevant information, be it categories, be it structured data, be it some key value pairs, right? We use them to help the user move forward in their journey, essentially to help them find to narrow down their intent, so that they give us a really strong signal to show highly relevant items.
It's not always, and it's important to remember that it's not always narrowing the query. Sometimes we need to get users to broaden their queries for when they're searching for talent, for example. And they say, I want someone who knows TensorFlow. We can use the knowledge graph to say, you mean machine learning tools generally?
Okay.
So that broadens the match and increases the liquidity. So they have more candidates to deal with. So it works in both directions.
Absolutely. That's a great perspective.
Mike. Yeah. Okay.
Yeah, that's great. I just have 2 follow-up questions. So in the search and recommendation for the product graph, because my understanding that there are so many different shopping items available, right, in eBay, Walmart, right? Then how do you guys determine the granularity in order to best benefit those use cases?
Right.
By granularity, what can you give me an example? I didn't quite understand what you mean by granularity there.
Like just take for example the shoes, right? I mean there are so many different types of the shoes, right? If you really want to go very, very granular, I mean even let's say for Nike, right? Okay. Every year there are so many new.
I think this is the case that Zay was just talking about a while back, right? Navigation. We used to call them as guided navigation. So if somebody just used a very broad search term like shoes, right? You would actually want to show him: are you looking for running shoes? Are you looking for casual shoes, or are you looking for office shoes or something like that, right? So dress shoes, high heels, or something. So this basically comes straight from the knowledge graph itself. So shoes would typically be a node, and you would actually find its first level child, and then it's a matter of applying some sort of personalization on that, right? Whether you're a male or a female, and then be able to show things based on that.
Yeah, this conversation always, for me, turns into a discussion of whether we should make something a node or leave it as only a feature. And I don't know, I hope someone here does, any good criteria to use for deciding whether something's going to be a feature. You probably don't have a category for red shoes or red footwear, but you will have a category for running shoes. So how do we make these decisions?
Yeah. Mike, extremely hard conversations with taxonomists and product managers that I've had. And finally, what I have decided to do was, if it's part of the head query, then it basically becomes a node. If it's not, it's an attribute. It stays as an attribute, which is what you're referring to as feature.
Yeah. Say that again. If it's part of what?
So, head query. Basically, if people look for it a lot, if
head
for
query.
Reason,
Okay. Okay.
So we just use data to make that decision, because there was subjectivity all around, right? If it's always in the mind of the users, right? You want to connect with the users. If user calls, if for some reason somebody says purple shoes, are so popular, then there is nothing wrong in creating a node for it.
Right.
Yeah, this is indeed a big challenge, because at eBay we maintain
billions of products.
Yes, and then their attributes, right? So sometimes we decide, hey, maybe this gender should be part of the node, right? Sometimes we change our mind. No, it's better to describe it as an attribute, right?
That's right.
So add query understanding team, we try to accommodate both, right? If there is red shoes, we try to match, red against maybe there's a category and name is red, right? If not, we try to match it against the feature, right, or attributes.
Right.
So it's sort of like a pretty relaxed way to increase relevant recall.
So the problem I see with Karthik's approach is that if we use the head queries, then it makes it harder for us to develop a tree for visual navigation. Because the queries that come out of the head are rather ad hoc. They don't have structure, or what I like to call it, architecture.
Yes, you're right.
So this is why I get stuck on this issue.
Yeah, there's no easy answer.
I'm disappointed. I thought you would have an easy answer for me.
Yeah.
All right.
Yeah, we also get into this completeness problem if we purely depends on the supply or demand. So yeah, if we look at the query, so maybe people only care about 3 colors. However, if you just surface it, if you put a filter module, say, hey, you want to filter by colors, you only provide 3 colors.
3 colors?
Yeah.
Are you serious? Right? It doesn't sound right. So I guess there's still some human involvement. So either the supply or demand provides us a seed, then the taxonomist or domain specialist comes in and enrich us with the seeds.
Yes, I'm thinking about constraints to give to the taxonomists and domain specialists.
Yeah, the constraint was this data. If people are looking for it, get it there, because that basically means this taxonomy can be used for ad targeting as well. Then advertisers are actually looking to pay for that as well. So that was sort of the rationale.
Right. So if we go along in the same direction, then again, talking about colors, we run into the problem is that some people use different terms for colors than others.
Yeah, you will have to do some sort of normalization. Yes, definitely.
Yeah, but then when you do normalization, the people who like to use a different term don't see it in the interface, right? So there's lots of issues. When I was at eBay, I remember we started working on colors, and there were 30 or 40,000 different color terms. Most of which I didn't know. So,
yeah, I thought I was colorblind when I saw those lists.
Yeah, after I joined, I started to know there's a burgundy. There's also really weird shades of purple. It's really sophisticated.
How about Kensington? That's one I remember. This is a color. I know it as a place.
Really?
Yeah.
Okay.
At eBay, if I remember correctly, it's one of the colors that showed up. Hawthorne and Kensington and strange things like that. Okay, so we have his top applications.
Okay.
Search and recommendations. I also mentioned analytics because different use cases will want to aggregate the data in different ways.
I see.
So that's another one.
Mike, I remember you mentioned there are some cases you thought it will work, but it turns out it doesn't. So do you mind sharing?
Some cases of what? Of
Like,
applications?
Of applications, yeah.
Oh, I don't remember right now. Move on and I'll try to remember.
Okay.
Do you remember anything of what I said?
No, you just, I remember you mentioned, there are some cases that the KG will help. Some cases it turns out it did not. So curious about which cases that you tried, but it did not work. Or anyone else has any lessons shared.
Yeah, that's a good one. That will require some more thought.
Yeah, but we can move on.
Okay. Great. Yeah. So just now, I think we also talk about the recommendations, right? So actually, I think one of the issues that we are facing in Pinterest regarding the recommendation is that for the cold start, let's say for some new
Yep.
right on the shelf, how we are going to make this recommendation effective. I think this is especially important, right, for the small business during this COVID-19, because I have one friend, I mean, even they open a shop in Pinterest because of the COVID-19. Any ideas and thoughts?
One approach might be we try to represent those items, those users, right? And then you derive a similarity.
Mm-hmm.
And use similarity to enrich your demand data, right? Normally for a popular item, a popular category, or popular user, you have past engagement data, right? Now, there's a new user or new store, new item, or new category comes into play. You can use a semantic understanding or semantic representation to drive similarity. You can then use that to fill in some missing demand data, right? To help you solve the cold start problem. You can also to think of those similarity as some sort of probability, and use that to drive your experience. Okay.
I see.
Yeah,
So
just some
maybe,
ideas. Yeah.
Maybe a part of this discussion is what kinds of attributes do we use to describe products?
Yeah.
So I'm sure we use things like color and size and company and price, but what about use cases or purposes of the product? So we can find competing products, for example, or similar products. Do you do that?
Who are you asking? Like,
I'm asking, I think, and eBay and Pinterest, I think you have products, and I'm wondering what kinds of attributes you use and find effective. Because I'm curious, for example, about this attribute of, what is this used for? So we can aggregate products by their use cases. And I'm wondering if you do anything like that. So we have the example a minute ago of running shoes. Cool. Do we have a category for equipment for runners or running equipment, which would be a use case category? Do you have attributes like that, or is it kind of built ad hoc?
No, I think running at Walmart at least was an attribute. I forgot the name of the attribute that we had. Yeah, I'm not able to recollect the attribute name, but
at Pinterest, what we do is we have some attributes to describe all the products.
Right.
So we first have the product categories. So that's actually the major categorization for all the products.
And that's what I'm trying to ask about is how do you define the product categories? Is it in terms of how the product is used, or what the other product attributes are?
So as for how to define, we actually started from the Google product taxonomy that the merchant provided to us. So use that, then together use that to bootstrap into a smaller product graph, a product category set.
I see.
So yeah, that's the major one. We have not tied it to any use case. Say, okay, running shoes or like a knee protector is for running purpose.
Yep.
So we haven't done that, but that's actually something I'm thinking about.
So this is a requirement I heard of. I heard about for a product taxonomy is how can we define competing products?
Competing products are used,
which are products that are used for the same use case.
Yeah.
Saying Nike shoes versus Adidas shoes? Are they
No. So you
competing?
have running shoes, and then underneath running shoes, you have multiple brands and colors and multiple other things. But you're aggregating in terms of the use case. These are for running. These are for hiking. Right.
Okay.
These are for orthopedic purposes, therapeutic purposes, etc.
So are you saying all the products under the same purpose are competing against each other?
Yep.
So they are competing, and they are also actually a substitute. You can imagine they're a substitute.
Yeah, exactly. That we take this to be the same thing as competing.
Mm-hmm.
So I'm wondering if you're doing something like that and doing something similar at eBay, and whether
Pinterest
it's worked out or not. Not yet. Okay. Sure.
Yeah. At eBay, we're not doing that, although we are really thinking along that line. Because sometimes if people are looking for luxury item, right?
Yep.
Say Gucci bag, you may not want to replace that with a really cheap item, right?
Right.
But another high-end, brand handbag may suffice. Right?
Exactly.
We are not capturing those kind of relationships because it requires a lot of domain expertise, right? Like Adidas and Nike are probably, at the same level of quality, right? But some, unknown brand, right, versus a name brand in a parts, category may be okay, right? Because I'm just looking for a particular part, right, to fix a broken piece of something.
Yes.
Yeah, then the brand may not matter that much, right?
Right.
As long as the size and specifications fit, right? But we are really thinking along that line to figure out, what are the replaceable kind of thing, what are sort of like a downgrade, right? If you're asking for X, but if you get Y, you feel like, hey, why am I getting this? This is not what I have in mind.
Hey, I'm thinking of related products that serve the same purpose. So you could do things like running shoes, or you could do things like, I don't know.
So we have some categories.
Spreadsheet software, for example, and then you have an aggregation that will show you, Google Sheets and Excel and these kinds of things in the same place.
Correct. We do have attributes or features like theme, right? Or different styles, right, for different purposes.
Right.
But I don't have the feeling that they are used in a global and very consistent fashion.
Okay.
It's kind of ad hoc, right? One catalog designer may say, hey, this dress is for summer, right? The style or the theme, right, for summer, right? But then in some other places, right, another catalog designer may just, put it as a totally different attribute. Right?
Okay. Interesting. Thank you.
Sounds great.
Yeah, one challenge is as the graph or the trees are getting bigger, and also as there are more and more attributes or features or properties, whatever you call it, right, tagged along with those, with that particular graph, right? Maintaining consistency gets harder and harder.
Yes, much more of a headache.
So coming back to the co-star problem, the approach that you proposed, like basically leveraging the past engagement of the similar product to give a jump start of the newcomers. So have you already applied it, or?
Yeah, well, we are sort of adopting that line of thinking when we are providing guidance.
Okay.
Because if you think about it, for features like a brand, right? There's thousands of brands, right, for certain categories, right? How do you surface them, right? What if all of a sudden there's a new model, new brand that comes in? Right? How do you deal with that? Right? Do you just allocate a particular slot, right, for those new item, right, new attribute, new feature, and then decay, or do you use a probability-driven approach, right? Currently, we believe using probability is more fair.
Yeah, I agree. I think for the engagement approach, actually, we use some in some of the growth services. I think one thing we found that is the diversity problem. We often, they just, recommend a lot of similar things because those things that are ranked the highest if you look at just the engagement. So we also, I think we also receive some of complaint on that as well.
So, yeah, if it's pure demand driven, if it's pure demand driven, it can have a position bias and easily form a feedback loop, right? Mm-hmm. So you only show those things, and those are the things people only see. Of course, those are the only things people only click on, right? So then you get stronger and stronger demand, but then the other stuff, right, don't really get a chance.
Mm-hmm. And actually, that's one of the applications of the knowledge graph is to fight diversity bias, is to improve diversity, mm-hmm. right? Yeah. Because you can sample from different items that have the same frequency or same popularity, and then you can just sample across whatever attributes you have in the knowledge graph.
Yeah, that's right.
Yeah.
Karthik is waiting.
Yeah, I wanted to add something here. I think one of we did conduct an experiment at Walmart on the school start problem specifically, where so the way we were structured, right? The personalization of the recommendation systems were actually managed by the customer experience team, and we were, and I was part of the catalog organization, right? So the knowledge graph initiative was inside the catalog team, and one of the promises that we made was that we can solve the cold start problem by actually finding product similarity just by looking at product signatures, right? By product signature, what I mean is we had a way to sort of identify what are the most important or significant attributes for a sort of certain product type. So when I say product type, we're talking about sort of the leaf node in your taxonomy, right? So at that level, we can actually tell you what are the most significant attributes, and typically they tend to be around 4 or 5. So if you're talking about shoes, it's going to be color and size, and maybe another one, right? So it's going to be a handful of attributes, and then you take those attributes and see how far off the other attributes are. So we ran an experiment on, if I'm not mistaken, again, it was on the home category. We took 3 million products, and we just found the relationship between each of them, between every product within the same product type. And it was a limited scale experiment. The result was actually positive, but we were not able to sort of scale that model out and roll it out in its entirety. Basically, the idea is very, very simple. You just compute similarity score for every product inside that product type. So you go to the leaf node, compare every running shoe, if that is the leaf node in your taxonomy, every running shoe with every other running shoe. But you sort of build some smarts around it by saying, same color and similar color, and then be able to use that and apply it during the cold start as part of your recommendation system. So our problem was we just couldn't scale it.
Mm-hmm. Because Walmart has too many products.
Too many products, and imagine comparing every product with another product, right? Especially right. For home, I'll tell you the category product type where we got stumped. It was carpets. Rugs and carpets. There were so many carpets that we just couldn't scale that.
I see. That's great. So here I just want to ask Professor Renxiang. So in academic, did you see any novel methods that's suitable for recommendation and cost-out problems that
Yeah.
you think the industry?
Yeah, I think this problem was even started when I started my PhD. I mean, I think the cost-out problem, which can be possibly solved by introducing knowledge graph, I think was the first paper was about 50, I think 10 years ago or 15 years ago. But I don't think the methods, the idea of the methodologies in academia along this line of research has changed too much. So pretty much is we have a collaborator filtering type of model, matrix factorization kind of model, which is looking at the user item interactions, log, these type of things. And then maybe we have some user features and item features that are extracted from contents or profile. And then there was this knowledge graph about the items being added. So there's many ways academia have been trying to make use of the graph structure of the knowledge graph on the item sides. I think at the very beginning it was like some type of label propagation kind of idea, and then more recently I think this was changed to this graph neural network becoming very hot. I think the essential idea is like you have this knowledge graph, and you have your end task objective, which is optimizing the error rate of the I mean, if we're talking about ranking, then it's just optimizing some ranking metrics of the recommendation. But together, you are learning some parameters of the graph network, which is trying to represent each of the items as a vector representation. And the benefit of graph network is only to just make the feature representation, the fixed size vector representations to be more capable of memorizing the item's semantics in some sense. But the essential idea doesn't change too much. So even you date back to 5 years ago, 10 years ago, people have been creating that vector representation for the items, but just using different technical approaches. Yeah.
Yeah, Pinterest heavily leverage like an engagement graph to learn the embedding for each pin. So I think engagement could be one type of the edges, and the other type should be like a content-based, semantic-based. So we should definitely combine these two and learn the embedding to reflect both type of similarity. Yeah.
All right, so that's great. I think, I think for this topic, I think there's really a lot of things we can continue to discuss, but due to time limits, shall we move on to the second topic, the data and technologies? Then, so regarding this topic, I think the first question coming in my mind is that for the data, although in the industry we know that in the company itself, right, we have plenty of internal data. But the question is that do you see the need that we should leverage the third-party data? If there is, I think definitely how to handle the third-party data, how to do the normalization, how to denoise it, might be something that we can discuss.
I would say that's the key topic. So systematically, when I try to leverage external sources or open source data, half of the data is good, but I don't know which half. And the rest of the data is bad, and it interferes with everything. So I have a very negative view on the usefulness of Wikidata and Wikipedia and all of these kinds of things. So it seems to me that if we could come up with a way to validate external sources of data, then it would become much more useful. They would become much more useful. But at the moment, we can't review it, and there's too much noise to be able to use it off the shelf. So I have a very hard time with external sources.
Yeah, I have tried my hands at that, and I've failed miserably. In fact, I did not even trust open data. Right? This is GS1 data. Have you guys heard of GS1?
No.
Yeah, I heard of it.
What's this?
Okay. GS1 is basically the standard for issuing GTINs. So they basically issue all the GTINs and UPCs for products. So you expect them to carry the the product metadata at least, right?
Right.
So I remember,
yes, I've seen that, and it's a
yeah.
mess.
It's a mess, right?
Yeah.
So I spent about a month chasing those guys, working with them, and then realized that they got nothing.
Yeah.
So
Yeah.
so third party data.
Isn't that related to the GPC data?
UPC.
Okay. Ah, yes, universal product categories.
Yes,
Yes.
product code. Yeah,
Oh,
yeah.
God.
Like the barcodes.
What a mess.
Barcodes. Yeah, exactly.
Yes,
So
exactly.
so yeah, it really didn't get us anywhere except that I lost a month of my time.
Yeah, I have a very, very similar experience.
Okay. So, Joe, any insight on this?
Help us,
Yeah,
Joe. Save us.
Well, sorry, I can't save you. Data noises, right?
We're beyond saving.
That's a billion-dollar question, right?
Yeah.
But it seems to me that there are pockets, right, in the open data, right?
Yes.
That quality very decent.
How can we find them? How can we find the good pockets? That's my question.
Well, for us, we kind of look at a particular use case and application, right? It will be manual work, right? Take UOM, right? That UOM portion of the Wikidata is quite decent, right? Because it describes all those units and conversion, and then we can really run tests, right, against it, right? Does this conversion look right, right? We can compute it. But for general purpose graph, it is indeed much harder. Maybe we can check the provenance, right? If it's from a reputable source, right? Then we can, trust it more. But, that's also hard.
So we looked at the UPC. We looked at the North American Industry Classification System for Industries, which is what's most widely used in the US, and it's required by the US government. I looked at lots of government taxonomies, and they're uniformly a mess. We have to use them for compatibility with external stakeholders, but I have a long list of negative experiences with these things. So
yeah, it is indeed a challenge, a big one, because here at eBay we map sometimes an item to a product, right?
Right.
Using maybe GTIN or UPC, ISBN, right?
Right.
And then you will notice discrepancy, right? Sometimes you see a pair of shoes have two different sizes. The correct size is offered by a seller. Incorrect size is inherited from the product, which is really mind-boggling, right? Why would these two disagree, right? I'm not even talking about different countries that have different size definitions, right?
Exactly.
It's the same country, but it's just by inheriting product, right, from a third party. That's indeed a lot of challenges.
Do you have tools in place to detect these kinds of anomalies? I mean, anomaly detection sorts of things?
Yeah, that's a very good question. For certain features, if we know there's sort of like a functional property, right? Like if it's really a size, well-defined size in US market, we know the value should be single valued.
Right.
Okay, then we can detect. But if it's in general a multi-valued attribute, take color, right? Because a pair of shoes may have 98% black, just 2% pink somewhere, right? You will see multi-valued, right, for that item.
Right.
And that's usually much harder to deal with.
Okay. Yeah, I keep pushing to get the engineers to look at different approaches to anomaly detection. We have a lot of legacy data. We have a lot of external data that we would like to use, and it only creates only creates confusion, because we really don't have any good tools to say, this is a normal skill for someone with this job title to have, right? And it's not something anomalous, or this is a normal job position to have in this category, or this is, I'm still looking for tools to help with this kind of anomaly detection.
Cool. Yeah, thanks. So regarding regarding the tools, yeah. So here I just want to ask. I think what kind of tools we are choosing might be also related to the scalability, right? So actually, one thing I think, Mike, I think one thing you also mentioned is that right. So different use cases, right? They might have only one projection of the graph as a tree, right? So in that case, do you suggest that we put everything in a huge graph DB, or we just have a virtual graph? I mean, defined in some ways, so that if somebody wants to have this projection, they just call the pipeline to get the nodes for the tree.
I would say the second one. I don't think we can. It's protecting us if we don't build fixed trees, right? In my experience, it's all the time people say, oh, no, my tree has to be different. So there's a lot of that. I'm not sure how to do that best, if we should be storing just entities with an array of attributes and then generate trees from that, or if we can do something different. If we have graphs, then we definitely, in my experience, need some way to partition the graph and show it one way or another.
Then in that case, what kind of rules we need to impose? Because I think definitely we cannot let people, I mean, just without any rules, I mean, try to do whatever they like.
Yes, exactly.
You have some risk, right?
Exactly. So one criterion that comes up frequently is liquidity. So don't show me categories that have fewer than X items.
Mm-hmm.
Okay, that's one. There are, I think there's a criterion of relevance. I mean, only show me the things that I'm interested in. So that means parts of the tree,
mm-hmm.
or parts of the graph. And again, these things vary a lot. So in recommendation use cases, the ask is for as much detail, a deepest tree as possible, because they want to provide more detailed recommendations. But for ads, for example, they're worried about liquidity, right? So they usually want to go broader, and they want more general categories so that they can have more people viewing the ads. We find that same thing with talent. When they're searching for talent, they want more candidates to look at, more relevant candidates. So they don't want to even hear about a deep tree.
I see.
In these use cases. So there are some differences there. Yeah, I think relevance and liquidity are the two top criteria, I would say.
Great.
Yeah, one approach that might be useful is to sort of predict, right, the category for your input. You have a graph or taxonomy, then by looking at the past behavior, for your given input, right, the most engagement are in, say, category 1, 2, 3, right?
That's right. A relevance metric, as it were. Yeah.
And that can be a good clue, right? Where you should focus on, right? If these 3 categories are sort of siblings, then you can roll up, right? If there's really diverse across different area, that usually signals the input has a broad intent, right? So you can use this sort of to drive different experience.
I see. Sounds great. Yeah. So just want to follow up on this. I believe that in eBay, I think as well as Walmart and other companies, right? So the scalability, I think this is the key thing, right? So just in your experience, as well as Karthik's experience, how do you deal with the scalability? What kind of database you're choosing to address this scalability problem? And also in the e-commerce world, we also need to do the incremental and emergency updates, right? Then for this, in addition to the scalability problem, what's the solution to resolve all these issues at the same time?
So our database. So I'll take it, one step at a time, right? So database that we chose to use was Cosmos. There weren't a lot of options, to be very honest, at Walmart, because you were sort of we were in a situation where we were forced to sort of move towards Azure, and we couldn't run our own VMs on Azure. We were just asked to use managed service. So basically, you're cornered. You had no choice. So we used Azure Cosmos DB graph data model for our purpose. But having said that, it had its own pluses and minuses. It came with, we use LPG and Gremlin. So the first order traversals were pretty quick, and the latencies were acceptable. All of that was fine. Adding new nodes was fine, but updating existing nodes, relationships, and stuff were actually really bad. So what we did was we broke our use cases into two. One that was first order queries and first order traversal and simple lookups, right? Those were pretty fast, and anything that looked more like an analytic workload, we had a copy of the same data in our Hive tables, and we were able to sort of run Hive jobs against that. So that is how we sort of handle this use case. So we had written some UDFs and UDTFs to help us do some level of traversals. So the graph data that's sitting in Cosmos was sort of flattened out and put in Hadoop as well. So we separated the OLAP and and the analytics, the online and analytics part into two separate use cases. So data was duplicated.
Great.
That's very good insight, Karthik. Yeah.
Thanks.
The analytics part and also the serving part. Yeah, the duplicate data in different formats.
Yeah,
that's a great insight. Mm-hmm.
Storage was cheap, but we always had, it had its own pitfalls. We had trouble keeping them in sync, in the sense that one of them was always ahead of the other. So you have to sort of manage that.
Mm-hmm. Yeah.
Right. Here at eBay, we don't have a big KG yet. Okay. So then the scale is not a concern, right? Pretty much it fits in memory, right? Mm. And the KG is not updated frequently. But we do have the trees, right? Trees have a lot of properties or features. Features do get, updated a lot more frequently, maybe on a daily basis, right? Then we have one of the NoSQL databases, right, to hold those cache of the data, right, and push them to the service layer as sort of the middle tier, right. That works well in practice. A bigger challenge is take UOM, right? Do you choose to do those kind of extraction, entity extraction, canonicalization at runtime, or offline, right? Because a query comes in, it may match, say, 100,000 items, right? To run those 100,000 items through a deep learning model, right, it's probably not going to fly. It takes too much time, right? So then you have to make a choice. You kind of have to offline do this kind of work, right? To extract, to check with the knowledge graph, right? To canonicalize and then store, right? The URIs, right? Together with the item. Then query time you can use it. Otherwise, the latency and throughput may be a huge challenge.
That's a great point.
Yeah, that's the problem we had with machine translation when I was at eBay. There were significant latency issues, so we had to do some really significant caching.
Yeah, I think that's pretty universal everywhere now with deep learning model. It's relatively easy to stand it up, right? But to scale, to make it serve, thousands of requests per second, that's really difficult. Okay.
Yeah.
Cool.
Cool.
Yeah. Then regarding the technology, I just have one question for Xiang. So in Pinterest, I think currently the way we utilize the new machine learning models is just like I think for the first version, probably we just try some naive methods. Then after this in production, then for the later iterations, right, when we try to do some incremental improvement, then we may try different methods that's new in the academic. So for your point of view, I mean, how to make the new technologies adopting in a faster way or in a more efficient way? So do you have any suggestions on that?
Yeah, that's a very good question. Actually, I want to comment on. I start seeing a bigger gap regarding the useful techniques that we've been developing from academia and whether they can be deployed in a very scalable way in industry right now. So you can see, like in my talk, I've been kind of abstracting out those model architectures as just a black box. And I think right now the common practices of those black box is usually a transformer type of neural architecture, or what we call pre-trained language models. And this can be applied to a huge range of different NLP tasks, from entity extractions, paraphrasing, question answering generations, ranking, all sort of things you can think of about natural language processing, and they've been doing very good. But these models by themselves, like you said, it's not really easy to deploy at a very large scale. I think right now, I don't know about all the other companies' status. I think only those very big companies, I know they have a very strong infrastructure support to deploy, let's say, a BERT large or some kind of large language models on the fly to facilitate search recommendations, all sort of API calls from other, I think, downstream products to get entities, to get sentiments, things like that. So I think it sounds to me this is more like a gap that need the data infrastructure, the machine learning infrastructure to catch up. But it's also very, very hard for and very costly for medium-sized, small-sized business. So that's kind of a question. Actually, I want to ask what you guys are encountering, rather than I have an answer in mind. Yeah.
Yeah. So in my opinion, I think let's say if a company-wide, if the company can provide a very good machine learning training and deployment platform, right? So let's say if academic people, if you can, let's say, package your new models somewhere, then we can just dump into this company-wide machine learning platform. Then we can quickly.
Is this a GPU computing platform or still a CPU based kind of a cluster?
I think we at the moment The Pinterest is going to build a scalable machine learning platform. I think, Ray, you have more context on that, right?
Yeah, we have some GPU clusters, not as big as most large companies, but we do have some. But because most of our models are relatively simple, so the majority of them are trained on CPUs.
Yeah. So that's my point. I think there's these huge performance gains from these transformer models, which has to be run on not even small GPUs, GPUs with large virtual memory. So that's like we think about like TPUs or other kind of infrastructure that like Google hosts or Facebook hosts. But that would really give them a huge margin of good performance if they can deploy that real time in terms of doing all sort of natural language type of understanding and generation. So I think probably there will be a wave of how the company is going to catch up on this infrastructure to get really to benefit from those technology advancements from natural language processing community.
Okay, so it seems like the computation power is one limitation, and the other one I can think of is like the code sharing. So if academia publish some paper, if they don't share the code, it's really hard for any machine learning practitioner to re-implement that.
I feel like the code sharing culture in machine learning community been doing better and better these days.
Better and better. Okay.
Right now, if you don't release code, your paper might get rejected.
Oh, okay. That's good to know.
But that's, I mean, the code of paper is totally different story than the production level code. But I think we're seeing some good companies like Hugging Faces, even the companies like Fair from Facebook or TensorFlow from Google, they've been doing pretty active jobs in releasing some of their code, high quality code, and making both research and maybe some prototyping in industry much easier than before. I think it's much better than, like, say, 5 years ago when we want to test some new ideas, new models. Yeah,
glad to hear that's not a blocker. Okay.
So yesterday, I was at ISWC, and I noticed that some of the sessions have, a label annotated, so partially reproducible, right? Fully reproduced, right?
Okay.
I was, oh wow, this is new. This is cool. Okay.
Yeah.
All right.
And plus, I mean, some of the research, I think in NLP right now, the things change in the past 3 years, 5 years is industry companies are leading the research frontiers rather than only the academia institutes are leading. Also partially because they have the computing powers. So they can do, let's say, language model pre-trainings, train a model with hundreds of GPUs for a week and create a huge model. Yeah, sorry for the noise.
Yeah, that's a good point. All right. Thanks for everybody's point on this topic. Due to time limit, so probably we can move to the next two. We can just go through very quickly on the talent and team building. So I believe that Ray and Mike, you want to share more on this. Then after that, we can just go to the future training. Just each of us just give 1 or 2 sentences on what kind of challenges and future in our domain.
I think, Mike, earlier you mentioned that to let the linguistics or taxonomies report to engineer manager doesn't make sense. It's hard to evaluate.
Well, no, I didn't want to say it doesn't make sense. I want to say it makes it difficult for the engineering managers.
That's true.
Right? That's all. But my position is definitely that we need teams that are making with both kinds of talent.
Yeah, maybe I can share how we do it. So when we create the taxonomy, we actually heavily leverage some taxonomists and product specialists. And we also leverage the PMs and legals review.
Yes.
like ads PMs or growth PMs review. So basically, we just temporarily form, whenever we want to make some changes, big changes, we temporarily form a virtual team. So like those taxonomists or PMs, they don't report to me. So just a virtual team, then we agree on some goal and timeline, then we just work together. Then after the project is over, we just go back to our normal job. That seems to work well because none of them are full-time on the taxonomy. So what's your experience?
My experience is that when the taxonomy team was separate from the engineering team, that the engineering priorities focused on anything except for the tools that the taxonomists needed. So when the teams were not actually partners, then it was very difficult to get tooling and improve the process, the taxonomy, the labeling and taxonomy building process. So that's a real, and I've seen this at several different places. That's one of the reasons why I think, so I've seen this change, and now there are teams where there are taxonomists and engineers on the same team with the same manager. And I'm finding that works very much better than either outsourcing to another team or outsourcing to an external group. And the ad hoc arrangement that you seem to have hasn't really worked for us as very well either, because you need the communications, and what that ends up doing is it means that the taxonomy team is orphaned. They have no tools, they have no engineering support, and to scale this up, we need engineering support.
That's true.
So that's a big gap that I've seen in several different places.
Okay. Yeah, I think if they have enough work to do, the taxonomists, they have enough work to do. I think
more than enough.
Okay.
Yeah. So
that makes sense.
I see the process in
I
see the process in two parts. One is building the taxonomy, and the other one is leveraging the taxonomy for applications. And leveraging the taxonomy is where all the engineers work. And building the taxonomy is just, that's their problem.
I see.
So this has been my experience in several places.
Okay. Well, we'll try to make our use cases more to form a formal taxonomy team as taxonomists. Okay.
Yeah, that's part of, because at the scale that we work, it's not good enough to have taxonomists working manually. It just doesn't work.
Okay.
So.
All right. Cool. Thanks for sharing. Any other people have any opinions on this topic?
Well, at least here at eBay for this project, we kind of have a virtual team, right? So people are building NER, people are building the KG, the resolution, and the folks working on search kind of have this virtual environment, right? But we do have a common sort of set of metrics in mind, right? Sort of search engagement metrics that we have in mind. But it's indeed a virtual team. Virtual team has its pros and cons, right? You don't have to move people around physically, right? Which can be a challenge. But then sometimes, different sub-teams may have different goals, right? Because it's not their sole job, right? It's not their only job, right? They have some other priorities. So that can slow things down, okay?
That's a big issue.
Yeah.
Great.
Okay.
Yeah, so I had a similar experience at eBay because I built the team there that developed the data for the machine translation systems, the data, training data and evaluation. And that was within an engineering team. So that started to work well.
Okay. Yeah. Yeah, as I said, I think if we have enough work to do, it makes sense to form like a consolidated team. Yeah.
I've never seen a taxonomy work with not enough work to do. A taxonomy team with not enough work.
So I need to tell this to to my boss, to enlarge our team. Okay.
Yep. I'll tell it to you. I'll tell your boss too.
Thank you.
Since now we are already talking about the future, so probably I think in this session, everyone just describe one or two future trends or challenges you are facing in your domain.
I'll go back to taxonomy construction, and I'm desperately waiting for Xiang to give us some better ways of building taxonomies so that we can scale our efforts.
Yeah, I think I think what I learned from working on this knowledge graph for the past few years and also talking with the industry people is, I find out that every team or group of people have very different use cases, and when they say I want to build a knowledge graph, they probably are thinking more from their own use cases. So they have a very customized knowledge graph, and this knowledge graph, later on, when they want to say, I'm going to make this effort bigger, so I hope more people in the company can appreciate it and join this force, and they will find out the divergence where the people don't agree with this schema, right? So I think it's very interesting. Like, do we really want to have a bottom-up approach in the company to create these efforts, or more top-down efforts? But the top-down efforts, it's hard because no one can decide what is the a general schemas that can work for the next few years for different products, right?
That's right.
But I think at least the top-down approach, it's a little bit. I think we can go very coarse-grained. Let's say you only have level 1, level 2 of the products categories where you are pretty sure this is going to benefit all sort of use cases, search recommendations from different teams. Then at least people will be able to see this as a service in the company, and then they can call this for their use case. I think that's at least making it useful, and then they can go down maybe trying to customize for different small teams. So I don't think we should aim for like a single big knowledge graph in a company. That might not be a very flexible plan. Maybe there's some high level backbone of the graph which is shareable across a bunch of use cases, but then when you really go into each individual team, they want to customize these things themselves. Maybe using the same infrastructure. That I think that seems to be more flexible to me. But I mean, I'm just talking this in a very ideal kind of sense. As far as the technique wise, I just think pre-trained language model seems to be dominating every individual small components that we talk about, like classifications, entity extractions, relation extractions, sentiment classifications. They've been doing really well on all of these kind of things. So there's a gap that the industry need to kind of close by improving their GPU computing infrastructure to really benefit from these resources. So I think that will also be a big trend. Yeah.
All right, sounds great. Then how about Kartik and Zhe? Do you have any insight on that?
Yeah, sure. I wanted to talk a little bit about the future at a smaller organization, right? Everyone here is at a fairly big organization, generating enough capital, and you have enough resources, right? So when I was at Walmart, these things were never a worry for me. In fact, it took us about 6 months to see some initial results from our knowledge graph effort, because it takes time, right? But it's a very powerful concept and a powerful idea, right? And it can provide really good results. But as a startup, do you think you have the time and resources to actually be able to go and build it? This is something that I have been thinking about in the last month or two when I'm trying to build the same thing. With limited set of resources in terms of human capital, you don't have a lot of budget to go and hire the best minds, one. And then in terms of computing power and resources, and you have too many priorities, right, as a startup, right? So this is something that I thought I'll just put it out there. The future, it looks like this is something just for the big companies at this point. how does a small startup be able to sort of build a knowledge graph and get going pretty quickly? Because it needs a bit of time and effort to be able to see that result. I'm not sure how many startups are willing to sort of, bet on that.
So Karthik, really good point. We are actually in of the same shoe as you, even though we're bigger. So we don't. I think the leadership doesn't want us to invest too much, have a huge investment to build a huge knowledge graph with a completely new infra. So that's why what we're thinking is building backwards. So starting from application, see what kind of problem are we solving. So pick the most hopeful idea application, then go backwards, build like a subgraph. Maybe not even in the GraphDB. That's why we actually post this question. Say, should we build a complete knowledge graph to host everything, or should we have like a virtual graph, basically connecting a bunch of relational DB, right? So maybe we can just start with relational DB with 1 or 2 type of edges, then show. Then that will be really quick. Then if we see some value, leadership will be more willing to invest. Mm-hmm. So that's how well we're working now.
Thanks for that insight. Actually, that was very helpful.
Mm-hmm.
I actually quite like that practical approach, right? The underlying graph database technology is important, right? But it's not that important, right? We must be able to show this application and potentially its ability to move a business metric, right?
Mm-hmm.
And here,
that's undeniable.
Yeah, our focus is really to pick a particular problem to get in this area, and then we need to extend to other entities, right?
Right.
Accuracy is important because at the end of the day, users must feel we are doing a better job, right? Also, coverage is critical because when we are doing a particular test, A/B test, right? We need to have the coverage, right? We need to be able to affect a big enough of a traffic share, right, to be able to have a reading out of a KG application. So accuracy and the coverage of traffic share, they're all very important. This is something we are extending beyond the UOM and looking into people's names, events, right? Locations, cities, whatnot, right? Trying to increase the coverage of the impact.
Yeah, I agree with Joe. I think I just want to add some points. I think my next year the challenge and the milestone is that try to transform the taxonomy into the graph. I think one of the important things for adoption is that we need to have an end-to-end solution, including the knowledge graph itself, as well as the machine learning downstream signals, even those UI design. We need to have a really a solution that every partner that can agree on. And also, we need to make sure that experiment metrics are good enough to ship the whole end-to-end solution. I think that's the key for the more knowledge graph adoptions in Pinterest.
I'm really sorry, but I'm going to have to drop off.
Mm-hmm.
We're running a bit late.
So I think we're running late. So we're done. I think we're done. So just a quick closing. So I hope everybody learned something from today's meeting. It's almost 4 hours. We recorded. We're gonna post the videos on the website. Is everybody okay with that?
Sure.
Okay.
Yeah,
awesome.
That's right. Yeah.
Okay, so this way you can share with your team members, with all your friends in KG. Then hopefully next year we can have the bigger summit. Mm-hmm. At least right?
In person.
In person, yes.
Yeah, that would be awesome. Can't wait for that, man. Hey, one question: are you planning to post something on LinkedIn or somewhere? Yeah.
Yes. I think after we finish, the website is updated. We'll post down LinkedIn to get it more publicized. Good idea.
Great.
Yeah.
Okay.
And,
thanks, everyone.
right.
It was a real pleasure meeting you and hearing from
All
all
right.
of you.
Okay.
Have a great one.
Thank you,
All right.
guys.
Bye.
Yeah,
We'll have
great
some
job
follow-up
organizing
emails.
this.
Mhm.
Appreciate it.
Right.
Great.
All right. Have a good day. Bye.
Bye now.